Welcome to my new video. In this video I would like to show how to assemble this 3D printed split ring planetary gearbox for the RR1 robotic arm. And here I would like to show more experienced construction and more experienced assembly based on some deeper insights and findings how the split ring planetary gearbox should work. It turned out to be very hard to properly align gears inside the gearbox. In my design I use 3 planets and sun, and as this is split ring design, each of the planets consists of 2 parts. One small part rolling around the smaller ring and one bigger part rolling around the bigger ring. The difference between the distance traveled along the rings causes rotation of the rings with respect to each other, and we get the output torque. However, planets, or both parts of the planets, are firmly connected together. The difficulty comes from the fact that the bigger part of the planet and the small part have different number of teeth, and that means that the smaller and the bigger part are rotated slightly with respect to each other. As we go around the planet, teeth on the smaller and on the bigger part are aligned differently at each different position around the planet. That means we need to align the mechanism very well to get smooth operation. The important property is that we have the number of teeth on both rings, on the output ring as well as on the fixed ring, is divisible by 3. This is because we need to have at least 3 positions around the rings that have the same alignment of teeth. So the same relative alignment of teeth on the small ring and on the output small ring and on the bigger fixed ring must be same at these 3 positions. This is because we need to place planets on these 3 positions where the relative alignment of teeth is identical. The concrete numbers of teeth is as follows. We have the planet that has 14 teeth on the small part, 16 teeth on the bigger part. Here divisible by 3 is not important, so we can have any numbers of teeth here. And on the rings, this is quite important. On the small ring that represents the output torque, we have 42 teeth, which is divisible by 3. And on the bigger ring that is fixed, we have 45. In case of the rings, it is important to have them divisible by 3. So 45 is divisible by 3, which is 15. In case of 42, we have it again divisible by 3, which is 14. We can also do greatest common divisor of these 2 numbers, of the number of teeth on the rings, and we obtain 3. If we get some higher number, such as 6, it means that we have more positions to place the planets. As we have 3 planets, 3 positions is enough. Okay, let's check what we have. We have here the rings, the fixed ring and the output ring. They are both printed from polycarbonate with carbon fiber to make them very hard and rigid. And the output ring, as we can see, is put inside a thin ball bearing. Here we have planets consisting in fact of two gears, the small gear and the bigger gear, that are firmly attached to each other. They are printed as one part. This is some gear. We can see it is reinforced by screws. The white part will hold planets and the sun in their correct positions. Before we attach the rings together, we need to place some washer between, because there is a small gap. And now both rings are attached together. Now the crucial step is to put planets inside the mechanism correctly. So we need to make sure that they are rotated correctly to make proper alignment of these. That's why we have marks on planets, and this mark should be rotated outside the ring. And we also need to place correctly the planets on the 3 positions around the rings. On these 3 positions, we know from the theory, as I mentioned already, we have identical alignment of teeth on the rings. That's why planets need to be rotated with the mark pointing outwards. We need to fix everything by the discs that form something I call the cage. Now the discs are with bearings inside, and pins from planets and from the sun will be put inside the hole of these bearings. Let's check marks again if they are properly pointing outwards the ring. And the white part is used to hold planets and the sun in their correct positions. Some washers need to be used to reduce friction. These washers are used to separate bearings and the planets and sun as well. Let's check if rotation is smooth and if everything, including the sun, rotates well. Washers and the other side of cage, if everything rotates well, and except screws, we are done. We not only do a better alignment of teeth in the new way of assembling the gearbox, but I also decided to change the bearing from the custom-made bearing composed by 2 rings with grooves that are positioned opposite to each other and filled by steel balls. It turned out to be quite hard to print grooves in the rings so that balls inside can roll smoothly. Instead, I used steel thin wall bearing that is placed so that the output ring can be put inside. I really enjoy here smooth operation with the new bearing. I omitted some steps in the previous part that I would like to show now. Here we can see how to attach rings together, one fixed ring and the ring with the bearing. And also we should not forget good lubrication of the gears, so to obtain smooth operation. This was also omitted the previous part, but this is a must. And it is quite helpful because lubrication helps to keep planets in their places without additional holding. We can see that lubrication helps to keep planets in their places without need to hold them, which is really helpful when assembling the gearbox. Finally, here I attach a part that is called cage, consisting of 2 discs mounted against each other that keep planets in their correct positions. How big the bearing is inside the mechanism. To reduce backlash, we need to be as precise as possible. If we don't follow the theory how to make proper alignment of teeth in the gearbox, then we can get quite bad results. In my previous build, as shown in this video, this is too bad. I did that without the theory, and I made the assembly by force. You can hear the sound in this video, which is too bad when teeth are matched together. And in the end, the result is that we get quite significant backlash. Now we will measure the weight of the gearbox that uses thin ball bearing with respect to the gearbox with the custom made bearing. The weight of the steel bearing itself is here. The gearbox with custom made bearing is 640 grams, and now the gearbox with steel bearing, it is 785 grams, which is 145 more. Now the weight contribution of two gearboxes, the two with custom made bearings, their weight is 1167 grams, and now the weight of bearings with steel bearing, they have 1387 grams, which is some 220 grams more. We need to take into account that the weight of the big shoulder joint is not that problematic because it sits directly on the base of the robot. Let's see the contribution of weight of steel bearings. The smaller one is 156 grams and the bigger one is 272 or 273. I also made another version of the gearbox. This one is for the RR1 revision 2, the orange one, and again it uses a thin wall steel bearing inside, and if you compare that with the gearbox for the revision 3, which is the yellow one, you can see that it is thinner, because in revision 3 I would like to increase the rigidity of the robot, which I believe can be partly achieved by having thicker gearboxes for individual joints. Thicker gearbox means that we have deeper wheels inside the mechanism and larger contact between individual gears. So I believe it will result in more rigidity of the robot. I made the new version of the gearbox for the revision 2 because I want to exchange the joint, as it is already shown in my videos, and this is because I was not satisfied by the operation of this joint. There are slight differences between the shape of the original gearbox and the new one, so the parts around need to be reprinted as well to reflect the new shape, and this is the opportunity to make them in some better way and make upgrade in the robot. I want RR1 revision 2 to collaborate with the upcoming revision 3, so this is the reason why I want to have revision 2 to be upgraded as well in terms of new gearboxes. This is the result. We have new gearboxes ready for the RR1 revision 3, as gearboxes for the joints represent essential step towards having a new robot. I believe that revision 3 will come soon. Thank you for watching. If you like the video, please subscribe to the channel, and I'm looking forward to your comments.